Hi everyone. Um, Today we're gonna learn about sketching quadratic relationships in vertex form. So again, quadratic relationships are parabolas. And once you learn about vertex form, it's the most graphing friendly form of the quadratic. We're going to be seeing three different forms over this unit. So we're learning to sketch a parabola given in this form, which is vertex form. Y equals a, and then in parentheses or in brackets, x minus h all squared. And this square here is what makes it a parabola because it applies to the x. This whole term is being squared, plus k. And then we're going to see what a, h, and k do through investigation. And we're going to learn to sketch a quadratic relationship, which is a parabola given in vertex form by identifying the vertex. So we call it vertex form because it's really easy to pick out the vertex. And also we'll be able to identify the step pattern just based off of the equation of the parabola. And those are the two things we need to be able to draw any parabola. And we're learning to describe transformations. So we'll talk about the different transformations that have occurred to the parent function. And the parent function is always going to be our original function, y equals x squared, that we've talked about. And I've got it on my iPad here. So that's, remember what y equals x squared looks like. And you can see the equation right there, y equals x squared. And you can see that we're going to be looking at the vertex form and playing around with these sliders to see what changing a does, changing h does, and changing k does. Okay. So far we've been exploring standard form of a quadratic function. Standard form is this y equals ax squared plus bx plus c, where we were filling in a table of values and then plotting the points to see the parabola. And we learned that the c value always ended up being our y-intercept. And that the value of a would determine the step pattern. Okay, so if a changed, the step pattern would change. When a changes, the step pattern changes, predictably. And we've also seen that changing b in the standard form will change where the vertex and axis of symmetry will be located. So by using the gizmo, we're going to look and see what does changing the a slider do to the parabola. Okay, and we have seen this a bit with our tables of values, but it's nice to see it here. So as a gets larger than 1, you can see that the parabola appears to get skinnier, but really what's happening is our step pattern. For instance, if I lock it in at 4, oops, I had it at 4 there. Lock it in at 4. That means when I go over 1, instead of going up 1, I go up 4. 1, 2, 3, 4, and that point right there at 1, 4 would be the new step. So over 1, up 4. Okay, and we call that a vertical stretch. It's like taking the parabola. If we go back to 1 here, I'll try to get it to 1. Yeah. Let's type 1 in here then. And then we increase it. It's like taking the ends of the parabola and pulling them up, okay, which is making it skinnier. So when we increase our, and you can see that the equation of the parabola is changing, that a is changing as we get larger and larger and larger. The parabola appears to get stretched and stretched and stretched, and we call that a vertical stretch. Okay, so what happens if we go less than 1 but greater than 0? So I'm going to, so here we are less than 1. We've gotten wider. Less than 1, even more less than 1, we're getting wider. Wider, wider, okay? And that's called a vertical compression. It's like taking our original parabola and pushing the ends down. We call that a vertical compression. Now, if we had zero, to type it in again. We just get the line y equals 0, because if we multiply anything, so if a was 0, we multiplied anything by 0, we would get 0, okay? But then if we start getting negative, so a little bit negative, moving our a slider, oops. Then what happens is if we're in between 0 and -1, we've got our wider upside down parabola. So as soon as a becomes negative, the parabola opens downward instead of opening upward, okay? And then if we stick between 0 and -1, we have like a wider parabola. But as soon as we get to -1, -1, there it is. We've got, so just the normal y equals x squared parabola, or y equals -x squared, would be the same exact shape, only upside down, and we call that a vertical reflection. So again, as soon as a becomes negative, we're vertically reflected. And then as a gets bigger than -1, we're vertically stretching. Vertically stretching, even though we're stretching downwards. This time it's still called a vertical stretch. Okay? So that's what our A slider does. So let's try to just write a little note about what the A slider does here. So what does changing the A slider do? So, oops, let's write this out here. If A is greater than 1, there is a vertical stretch. And the stretch occurs in a specific pattern. So I'm going to lock us in at 2 here. And we would go from our step pattern would be over 1 up 2, and then over 1 up 1, 2, 3, 4, 5, 6. So it's that 1, 3, 5, but the A multiplies it. Okay? Vertical stretch. And our step pattern becomes 1 times A, up 1 times A, up 3 times A, up 5 times A, etc. Okay? And then we also figured out that if A was between 0 and 1, we had a vertical compression. It was wider. The parabola got wider. 0 and 1, there is a vertical compression. So vertical stretch, like our parabola, gets skinnier, and a vertical compression, our parabola gets wide. It looks like it's wider because we're compressing it or pushing it down this way. Okay, and it's also in a predictable pattern with a step pattern of, again, 1 times A, but if A is like 0.5, then our first step would be up 0.5. And our second would be up 3 times 0.5, which would be like 1.5. And our third step would be like 5 times 0.5, which would be like up 2.5. Okay, so it's always very predictable. The A is like super important. It affects our step pattern. So A is greater than 1, we've got a vertical stretch, and our step pattern changes. Our slope changes quicker. And if A is between 0 and 1, we have a vertical compression. So we have like our wider parabola, and our step pattern is still predictable. 1 times A, 3 times A, 5 times A, etc. Often you can do like fit in the 7 times A if you've got enough graph space, with the A being a decimal or a fraction. And then we also learned that if A is negative, the parabola opens downward. So instead of being upright, it's like this, okay? And the transformation word for that is called a vertical reflection. So this being upside down, we call it a vertical reflection, which is, I use vertical reflection to describe it, but some textbooks or a different teacher might say it's reflected in the x-axis. So I'm going to just show you my gizmo again so you can see why they would say reflected in the x-axis. And whenever you see reflection, you're thinking of a mirror line, okay? So I'm going to just change the slider again to 1. And there's our regular parabola. Now if I change the slider to -1, there's my minus sign. -1. You can see it just flips upside down. It's got exactly the same shape. And this x-axis we could consider as being the mirror line there. Okay, and that's why it's called a reflection in the x-axis. Anytime you hear a reflection, you think of where's the mirror line going to be. In this case, the mirror line would be the x-axis. And we call it a vertical reflection because it goes from being up, facing upward, to facing downward. And up and down are vertical words. Okay? All right, so that's all the different things that A can tell us. So A gives us a lot of info on what the parabola is going to look like. So the next thing we're going to look at is what does changing the H slider do? So the H slider. So I'm going to start off just resetting this to +1, and we're just going to leave the A slider alone, and then we're just going to play with the H slider. Okay? So watch what happens with the value of H, also with the equation up here in red. So if I move my H, see my H is positive here, 1.7, and the equation becomes x minus 1.7 squared. And that's because there's a minus in our formula here. So even though H is positive, we see this negative and we're moving to the right. Okay, so we keep moving the vertex to the right. And I can show you, like this says show vertex, and you can see the vertex is 4, 0 when H is 4. But if you look at the equation, it says x minus 4 squared, okay? And that's because there's a minus built into the formula. So when H is +4, our vertex is at 4, 0. When H is +3, for instance, sorry. I'll go over here. 3. There we go. Then our vertex is at 3, 0. Okay? So H is positive, we're moving to the right, but it's got this minus sign in the formula. That's what often confuses things for people. Okay, so H is +3, but when we write it in the equation, when we replace H with 3, we get x minus 3 squared. Now what happens if we make H negative? Then we're moving the other way, we're moving to the left. And I'm just going to show you, I'm locking at 3 there, if I can. It's fiddly. There we go. All right, so look at the value of H. It's -3, but the equation is y equals x plus 3 squared, and I'm going to show you quickly why that is. So again, we've got our H value. So I'm going to write the original out here for a second, and then we'll just go over why the equation looks like that. So we had our H slider fixed at -3, and we can see the vertex is at -3, 0 right there. Okay? So if I look here, I've locked my A slider in at 1, I've locked my K slider in at 0. So if I'm just substituting A, K, and H into this general formula, let's see what I get. Okay, so I would get y equals 1, I'm replacing A with 1, x minus, and I'm replacing H with -3, all squared, and then K is 0 plus 0. So then this 1 out front, multiplying by 1 doesn't change anything, so I don't really need to show it. But here, x minus -3. Well, when you subtract a negative, you're really adding. So rather than having a double sign here, we would rewrite this as x plus 3 all squared, and then I don't need to show the plus 0 either. So even though H is -3, meaning that I moved the vertex left 3, when I look in the equation, I see it as x plus 3, and that has to do because there's a minus in the formula, and when I subtract a negative, I end up adding. Okay, so it's really important you understand that, so that you'll know where your vertex should be. Okay, so what does changing the H slider do? Okay, so when H is positive, the parabola moves to the right, and your equation would look like y equals x minus a number, so say like -4 squared, for instance. When H is negative, the parabola moves to the left. But remember the equation, when we look at the equation, it would look like x plus 4 squared, because there was that minus built in, sorry. And I just went over that with you, why it would look that way, okay? All right, and then the last one we're gonna look at is what does changing the K slider do? So I'm going to lock in our H slider at 0 again. And now we're going to, we've got back our original parabola, y equals x squared, and now we're going to play with the K slider, okay? So K slider, as I'm moving it, making K bigger, I'm trying to make K bigger, oops. Looks like there we go. So I've got my regular parabola, I'm moving my K slider. As K gets bigger, you can see my equations changing, x squared plus 1.1, and my vertex is at 0, 1.1. And my parabola is staying the same shape, even though you can't see all of it. It's just moving up if K is positive. It's just moving up, moving the vertex up. And then still staying the same shape, even though you can see more of it. And then as soon as K becomes negative, I'm moving my vertex downwards. Moving my vertex downwards. Okay, so that's what K does. So what does changing the K slider do? When K is positive, it moves the parabola up, and it moves up the value of K. And when K is negative, it moves the parabola down. And then another thing I wanted to point out here, I'll just do it in a different color. What does the H slider do? It moved it left and right, and so we call these horizontal shifts because it moves the parabola left and right. And then K moves the parabola up and down, so we call those vertical shifts because it moves the parabola up and down. Okay? So we've talked about vertical stretches when the A slider gets bigger than 1 and the step pattern changes. We've talked about vertical compressions when the A slider is between 0 and 1. We've talked about a vertical reflection. We've talked about horizontal shifts and vertical shifts. And those are all the transformations when we compare it to our original parabola. That was just y equals x squared, our very basic one. So vertex form, here we are. This is our most graphing-friendly form of all. So it turns out that the vertex V is always HK because H moves the starting point or the vertex to the left or the right, and K moves it up or down. So the new vertex, if it started off being 0, 0, becomes HK, which is great. And then A tells us a step pattern. So A is great because it tells us the step pattern. So it's always 1 times A, 3 times A, 5 times A, etc. And then if we talk about transformations, A is telling us if there's a vertical stretch or a vertical compression. And it also tells us if there's a vertical reflection. If A is negative, let me get a different color here. Remember, also, if A is negative, there's a vertical reflection. Which means the parabola is opening downward or flipped upside down, however you think of it. Okay? And then we have our H, and that's our shift left and right. Let's do that in pencil. So what does H do? Horizontal shift. Left or right. And then what does K do? Running out of colors here, see if I can find one more. Yeah. K is our vertical shift. Up and down. So there's our powerful vertex form, which makes it really easy for us to graph our parabola and also to tell what transformations it has, the parent function, which is just plain old y equals x squared, has undergone. Okay? All right, so there's a lot of info on that page. Make sure that you've got it all copied down before we move on to the next page. If you have to pause the video, go ahead and pause it. All right, so now we're going to look at this. So we've got our equation here, and this blue one on here, or it's the one that's already on there, is always going to be our y equals x squared, which is our parent function. We call it our parent function because it's the most basic parabola. Okay? If you wanted to exaggerate this equation, if we wanted to see how it would look in vertex form, well, if A is 0, no, sorry, if A is 1 and H is 0 and K is 0, then this equation becomes y equals 1 x minus 0 squared plus 0. And then I don't need to show the 1. X minus 0 is just x squared, and then I don't need to show the plus 0. So this is, you can think of it in vertex form, but you're knowing that A is 1, H is 0, and K is 0, okay? And then we know about our parent that the vertex is at 0, 0 right there, and then our step pattern is 1, 3, 5, over 1 up 1, over 1 up 3, over 1 up 1, 2, 3, 4, 5, and if we had room, it would be over 1 up 7, etc. Okay? So now we've got this new equation here that we're focusing on. So y equals x minus 2 squared plus 1. And then I've got spots for us to fill in. Well, what's the a value? So I don't see a number out front there, so it must just be a 1. Okay? H, so remember that our general form is this one right here, where there's a negative sign before the h. So the h is just 2, okay? And the k value is positive 1. And we talked about the vertex being hk, so for us that would be at 2, 1. So the reason we call this vertex form is because it's really easy to pick out the vertex. It's hk. So our new vertex is going to be at 2, 1. So there's our new vertex. Our step pattern, since there's just a 1 out front that we don't need to show, is still going to be like positive 1, positive 3, positive 5. Okay, so from the vertex, we would go on both sides over 1. I don't want to use blue there, I'll use green. So over 1, up 1 on both sides. Then from here, over 1, up 1, 2, 3 on both sides. And then over 1, up 1, 2, 3, 4, 5 on both sides. And then practice drawing in our, oops, I think I put this one in the wrong spot. Practice drawing in our smooth curve. And this one should have exactly the same shape because the step pattern didn't change as our parent function, but the vertex has changed, okay? And the equation of the axis of symmetry. So our axis of symmetry goes always through the vertex. So our new axis of symmetry is at x equals 2. And what transformations have happened from the original? So from the original, our vertex has been shifted 2 units to the right. So we call that, first one, a horizontal shift. Horizontal is left or right. So first we describe the overall transformation. It was a horizontal shift. And then I use a semicolon and I say specifically what it is. In this case, it was right 2. And then compared to the original, we've vertically shifted up 1. So we call that, overall it's a vertical shift. And then with after our semicolon, we describe what it is. In this case, it's up 1. So there's 2 things that are different. It's got exactly the same shape. In other words, we could say the parabolas are congruent. I could cut the green one out and paste it on top of the blue one. They're exactly the same shape because the step pattern stayed the same. But we've shifted it right 2 and up 1. Okay? All right, let's look at the next equation here. So we've got y equals x plus 3 squared minus 4. And it's giving us a place to put our values of a, h, and k. So again, if we don't see a different number out for a, it's just a 1 still, which means, again, we're going to have the same shape of parabola. H, so I see plus 3 here. And this is the trickiest part. I have to remember that that came from the minus in the formula, and the only way I could have got a plus there is if h was negative 3. Because when you subtract a negative, it becomes adding. So h is negative 3. And k is negative 4. And our vertex is always hk. So the vertex is going to be h, which is negative 3, k, which is negative 4. So that means the vertex of this one is going to be at -3, so 1, 2, 3, -4, 1, 2, 3, 4. So there's our new vertex. And you can see, compared to the original vertex, we've shifted 3 to the left and down 4, okay? And because A is still 1, our step pattern is still up 1, up 3, up 5. So let's do that now. So from my vertex, I'm going to go over 1, up 1 on both sides, over 1, up 1, 2, 3 on both sides, over 1, up 1, 2, 3, 4, 5 on both sides. And then if I had room to go up 7, I would, but I don't have 7 spaces, so I'm just going to try to draw it in as clearly as I can. And remember, because A is the same, and I made the parabola from the step pattern the same way, these are congruent. Even though I can see more of the green one, if I cut it out and lined it up on top of the blue one, it would have exactly the same shape. And our axis of symmetry always goes through the vertex. It's a vertical line, our mirror line. In this case, it would be x equals -3. And then our transformations discuss how our new parabola is different from the original one, y equals x squared. So this one's y equals x squared. And this green one is y equals x plus 3 squared minus 4. So they have exactly the same shape, so I don't have any stretches or compressions going on, but I have shifted the vertex left 3, because h is -3, and we call that a horizontal shift. Left or right is always our horizontal component. So overall it's a horizontal shift, but specifically we moved left 3. And then our vertical shift was down 4. K is -4, down 4. So those are the transformations that occurred. All right, let's look at another one. So here's our equation, y equals -2x squared. And again, sometimes you look at it and you think that's not in vertex form, but it is. Like I could exaggerate it. So remember, we've got like the y equals a x minus h squared plus k. So if it just looks like this, I definitely have changed my a. But for it just to be x squared, it must mean that it was x minus 0 squared, because x minus 0 is just 0, plus 0, okay? So when you see this, we know a is changed to -2, but our h is 0, must have been 0, and our k is still 0. So even though this doesn't look like it's in vertex form, I could exaggerate it so it did, okay? Which means our vertex is still 0, 0. Our vertex didn't change, okay, because it's always hk. So here's my vertex of my new one. And then my step pattern did change though, because my a is now -2. So instead of +1, +3, +5, I'd be thinking to myself 1 and then times a, remember? So I'm 1 times -2, 3 times -2, 5 times -2, etc. That's a time sign. Maybe I should make it look like a star so you don't think it's an X there. Which would end up giving us -2, -6, -10. Okay, and that negative is going to indicate we're going downwards. As soon as we see the negative there, we know that our parabola is opening downward instead of upward. So let's see what we can fit on here. Here's our vertex still in the same spot, 0, 0. So instead of going over 1, up 1 like normal, I go over 1, down 2 on both sides. Then from here, I'm going to go over 1, down 6. 1, 2, 3, 4, 5, 6. Over 1, down 1, 2, 3, 4, 5, 6 on both sides. And now that I've changed the a value from being a 1 to a 2, these aren't congruent parabolas anymore. If I cut this one out, it would be skinnier, it would look skinnier. We call that a vertical stretch. And our axis of symmetry, again, just goes through the vertex. So it's just going to be x equals 0 again, like our y equals x squared parabola. But what are the transformations that occurred? So it may look like 1 to you because it's only a that changed, but this is actually 2 separate transformations. So the negative sign caused a vertical reflection. And that takes care of the negative sign, okay? So it's separate from the fact that it's also being stretched vertically. I'm pulling the ends and making it tighter to the axis of symmetry. We call that a vertical stretch. So remember, the negative sign was already taken care of in the first transformation, the vertical reflection. So when I specifically say what type of stretch it was, I'm going to say by a factor of 2, not by a factor of -2. The negative was the reflection by a factor of 2, which means I'm doubling my steps. So instead of my first step being 1, my first step's 2. And instead of my second step being 3, it's 6. I'm doubling each of my steps. Okay, and that's why that says a factor of 2. Okay, that's how you would describe it. So those are your 2 transformations. All right. Next one. So here we have our next equation. Y equals 2 times x plus 4 squared minus 7. So we've got our original marked on there already. Our y equals x squared. And then we've got room to figure out what a, h, and k are in our new equation, given to us in vertex form. So our a value is 2. Our h value, so since I see x plus 4 here, I have to remember in my mind that the only way to get that plus, because there's a minus in the formula, must have been x minus -4 squared, okay? And then you don't write 2 signs, so they would write it as x plus 4 squared. So that means h is -4, okay? And then k is just the same as what it looks like in the formula, is -7. So that means our vertex is hk, so our new vertex is going to be at -4, -7. So we're going to plot that point on our grid. That's our new vertex. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Right there is our new vertex. And our step pattern, so we've got a 2 now. So remember, our step pattern is 1 times a, so in our case 1 times 2, 3 times 2, 5 times 2, or you could just write +2, +6, +10, okay? So you're multiplying the normal 1, 3, 5, and again, these look like X's, so I'm going to change them to stars here. And you're just multiplying each step by 2, or doubling each step. And then when we put that on here, so from our vertex, we go over 1 up 2 on both sides, because parabolas are symmetric. Over 1 up 1, 2, 3, 4, 5, 6 on both sides. Over 1 up 10. We don't have quite enough room, but I know I'm not going to reach there yet. And I'm going to draw in my parabola as best that I can. Arrows on the ends. Okay. And so that's the picture of y equals 2, x plus 4 squared minus 7. I did want to show you something else here, not with my gizmo, but with Desmos, which you guys all have. Desmos graphing calculator. Which you might find helpful when you are double checking yourself here. So if I were to type in this equation, I could use the Desmos graphing calculator to type in y equals 2, and then bracket x plus 4 bracket squared, and then arrow over, minus 7, and then you can see what your vertex is. You can see, like, if you pick a certain point on the screen, it'll tell you what it is, and you can see that you've drawn your parabola correctly there. Okay? So just a tool that can help you if you're unsure of whether it moved to the left or the right. If you're still getting used to it, you can always use Desmos to check your thinking. Okay? All right, so our axis of symmetry is always through the vertex. So in our case, it's going to be the vertical line x equals -4. And the transformation, so how is it different from the original, we call it parent function, y equals x squared. So we know it's been moved left, so that's called a horizontal shift. And that horizontal shift was left, so specifically, that's where you put your semicolon, left 4. We also know there was a vertical shift. So, and that was down 7, specifically down 7. And we also know that there was a vertical stretch because the parabola is skinnier. We've pulled these together more, right? So that's called a vertical stretch. And that is, sorry, I might be able to see that, by a factor of 2 because we doubled all our steps. So by a factor of 2 because we doubled our steps. All right, next one. Our equation is y equals -x squared plus 5. Again, you always want to compare that with the original vertex form. So ax minus h squared plus k. So if I don't see brackets, like it's a very, if you don't see any brackets, it's because h is 0. Okay, the only way to get just a plain x squared would be if h was 0, because x minus 0 is just x. So if I wanted to exaggerate this equation so it looks exactly like vertex form, that's what you would need to do. And that's another one of the maybe tougher things. You'd look at it and say, well, I don't think that's in vertex form, but it actually is. So our a value is -1, because there's a little 1 between the negative sign and the x squared. Our h value is 0, and our k value is +5. And remember, our vertex is hk, so in our case, our vertex is 0, 5. And our step pattern, so a is -1 now, and that means we multiply 1, 3, 5 by -1, so that's just going to make it -1, -3, -5. So it's going to have the same shape, but it's going to open downwards. That's what that -1 is going to do. So let's plot our new vertex at 0, 5. And then follow our new step pattern, which is over 1, down 1, down 1, and then over 1, down 1, 2, 3. 1, 2, 3, and then over 1, 1, 2, 3, 4, 5. It's symmetric. And then if I could fit 7, it doesn't look like I quite can. It looks like there's only 6 left, so I'm just gonna not run into that line there. Arrows on the ends. And there is your parabola, the graph of it. We need the axis of symmetry, so that goes right through the vertex. And it's still x equals 0, our vertical line. X equals 0 is the axis of symmetry. And how is it different from the parent function, y equals x squared? Well, it's upside down for one, so we call that a vertical reflection. Vertical reflection. And then, so that's our A value, -1, our vertical reflection. And it's also been shifted upward compared to the original parabola. It's been shifted up 5, so we call that a vertical shift. Anything up or down is vertical shift. And specifically, we shifted it up 5. And those are the two differences between it and its parent function. Remember, it maybe looks a tiny bit wider just because you can see more of it, but if we were to cut it out and flip it around, it would line right up with the blue one. It's congruent. All right, our next one. So there's our equation given in vertex form. So we should see here that our A is 1/2. Our H, because we had a +3 here, it must be -3. Remember, in order to get that, we've got x minus h squared. So in order to see a +3 there, it must have been x subtract -3 squared. And that's how we got the plus, because subtracting a negative makes a positive. And then there's no add anything or subtract anything, so our k must be 0. Which means our vertex would be hk, so -3, 0. So let's plot our vertex. So 1, 2, 3, right there is going to be our vertex. And our step pattern. So halving things, right? So we're thinking of 1 times 1/2, 3 times 1/2, or we're cutting our steps in half. 5 times 1/2. Well, or we can think of it as positive 0.5. 3 times 1/2 is 1.5, so positive 1.5. 5 times 1/2 is positive 2.5. And then if we kept going, you can already see the pattern. Plus 0.5, plus 1.5, plus 2.5, plus 3.5 would be the next one, ... And often when it's a fraction or a decimal, you can fit more steps in. So we'll see what we can fit in here. So starting from 0, 0, we go over 1 up 0.5 on both sides. So we're just halfway there, okay? Now we're going over 1 up 1.5. So here's like our 1, and 0.5 lands us on a corner again. So be really careful about that. Over 1 up 1.5 puts me on a corner. Our next step is 2.5. So over 1 up 1, 2.5. So we're on a halfway again. Over 1 up 1, 2.5. And then our next step would, if it fits, would be over 1 up 1, 2, 3.5, which does fit. It gets me right to this top corner here. And you can see that when we join this, our parabola looks wider than the original, and we call that a vertical compression. It's like we're pushing the ends of that down, and that's making it wider. And our axis of symmetry is right through the vertex. So in our case, it's going to be x equals -3. And transformations from the original, well, we can see that it's been shifted to the left. So we call that left and right is horizontal. So a horizontal shift. And that's going to be left 3. And we call this a vertical compression when it becomes wider like that. It's like we're pushing down on the ends. And what we did is we halved each step. So we say, we say by a factor of 1/2, because we've cut the steps in half. Instead of going over 1 up 1, we went over 1 up 1/2. Instead of going over 1 up 3, we went over 1 up 1.5, which is half of 3. So all our steps have been cut in half. So we've compressed it by a factor of 1/2. And I always like to remember that if I use the word compression, I'm always going to use like a number between 0 and 1, which is usually a fraction, sometimes a decimal, okay? And then if I'm stretching, like up here, I'm always using numbers bigger than 1, 2, 3, 4, 5, etc. Okay? So stretch goes with big numbers. Compression goes with little numbers, if you want to think of it that way. Always make sure those match. All right. We've got more of the lesson to complete, but I think we're going to stop there for today, and I'm going to have you do some questions. And then we'll finish this tomorrow, and you can finish the questions tomorrow. Because I can see on my reader here, this video is already 50 minutes long. So for your check your understanding, I would like you to do questions 1, A, B, C, and D. And when you're doing them, remember, even though I don't have the prompts there, what I would want you to do is state what A, H, and K are. Okay? It says to state the vertex, the step pattern, and the transformations that have occurred to the parent function. But in order to do that well, it's good to always know what your A value is, your H value is, and your K value is, like we did for all of our examples here. Okay? It just doesn't set it out as easily in the note. So you should think, okay, I'm going to figure out what my A, H, and K are. Then I'm going to state the vertex and the step pattern, draw my parabola, state my transformations. Okay, so you're going to try 1, A, B, C, and D. And then tomorrow we'll finish the lesson, or you will finish the lesson and finish the practice. Okay.